In the last lecture, we have discussed about the quantum mechanical scattering and tunneling across a rectangular potential barrier. Now, the thing is that we have, we have moved up to question number 15 in the last lecture. Actually, we have found out that, the value of A and B, and then we'll continue from there. Now, from equation 12 and 13, if you have to refer my last lecture from 12 and 13, equation number 12 and 13, we get C is equal to P1 plus P2 by 2P1 into F into e to the power I P1 minus P2 into L by H cross. So this will be equation number 16, and then we'll again read D is equal to, it will be P2 minus P1 by 2P2 and into F into e to the power I P1 plus P2 into L by H cross. So this will be equation number 17. Now substituting this value of C and D. Okay, substituting this value of C and D in equation number 14, which we have obtained earlier. Okay, so we'll substituting the value of C and D in equation 14. We get A equal to F into e to the power I P1 L by H cross by 4 P1 P2. Take a bracket over here and then write down 4 P1 P2, okay, cross P2L by H cross minus 2 P1 square plus P2 square, okay, into sine P2L by H cross. So this will be our equation number 18. Now what we'll do is that we'll just do a bit of calculation, and then we'll just write it down like this, and then this value can be written like F by A. F by A is equal to 4 P1 P2 divided by e to the power I P2L by H cross 4 P1 P2 cos P2L by H cross minus 2I P1 square plus P2 square into sine P2L by H cross. Now this will be our equation number 19. Here P2, as we know, it's given by P2 is equal to under root 2m into under root again E minus V naught. This is imaginary, okay, since E is less than V naught. So this has to be in a bracket. There is no bracket, there is no root over here. Now here we can write that P2 is equal to I under root 2m into V naught minus E, or P2 is equal to minus I under root 2m V naught minus E. This is the conjugate of it, which is equal to obviously minus of P2. So P2 asterisk is equal to minus of P2, or P2 asterisk square is equal to P2 square. So the complex conjugate of F by A is given by F by A asterisk is equal to 2 P1 P2 e to the power I P1A by H cross divided by 2 P1 P2 cos P2A by H cross plus I P1 square plus P2 square into sine P2A by H cross. So this will be our equation number 20. Now the transmittance T, okay, it is given by F by A into F asterisk by A asterisk. Now substituting the value of F by A and F asterisk by A asterisk into this equation, we will get 4 P1 square P2 square divided by 4 P1 square P2 square plus sine square P2A by H cross P1 square minus P2 square whole square. Here what we have done, we have substituted the value of f by a and f asterisk by a asterisk, okay, which we have already obtained, which is there in equation number 19. And after that, now now substituting the value of equation 16, okay, equation 16 and 17 in 15, we will get the value of b. So b will be p1 minus p2 by 2 p1 into c plus p1 plus p2 by 2 p1 into d. Now further we'll write, putting the value of c and d over here, we'll get, substituting the value of c and d which we have already obtained earlier, we will get b is equal to minus of sf e to the power I p1 l. This is l obviously. So here also in equation 20 also you just have to make it l over here. Here also l, and here too it's l. Now b is equal to minus f e to the power I p1l by h cross by 4 p1 p2 into p1 square minus p2 square, okay, into 2i sine p2l by h cross. So this is the value. Substituting the value of this f e I p1 p1a h cross by 4 p1 p2 from equation let's say from equation say already we have obtained, that is f by a1. So we'll substitute from there. So we'll get b by a is equal to minus 2i p1 square minus p2 square sine p2l by h cross divided by 4 p1 p2 cos p2l by h cross minus 2i p1 square plus p2 square sine p2 by h cross. So this is what the value of b by a is. B by a is equal to, again, minus I p1 square minus p2 square, okay, then sine p2l by h cross whole divided by 2 p1 p2 cos p2l by h cross minus I p1 square plus p2 square sine p2l by h cross. So its complex conjugate is given by b by a asterisk is equal to I p1 square minus p2 square into sine p2l by h cross divided by, this is pi l, okay, 2 p1 p2 cos p2l by h cross plus I p1 square plus p2 square into sine p2l by h cross, okay. So we have the value of b by a and its conjugate b by a asterisk, right? So what we do is that the reflectivity can be obtained by r is equal to b by a into b by a asterisk. Now what we do is that we'll substitute the value of b by a and b by a asterisk in the equation to get the value of r. So r given as the value of r after calculation, that is reflectivity, may be given by r equal to p1 square minus p2 square. You have to do a bit of calculation of your own. p2l by h cross divided by 4 p1 square p2 square plus p1 square minus p2 square whole square sine square p2l by h cross. So it is yet another equation. Now the value of r plus t, substituting the value of r and t over here, if we substitute the value of r and t in this particular equation, we will get that is equal to 1. Substituting the value of r and t, here we have the value of r and already we have obtained the value of t from here, that is equation number 21. And then if we put the value of r to be 22, then we will get the value of r plus t equal to 1 after the calculation part. Now the property of the barrier penetration has been entirely due to wave nature of matter. Now, and has been found to be much similar to the internal reflection of the light wave. If there are two glass plates having a layer of air as a medium between them, even there occur transmission of light from one plate to another, even though the angle of incidence is greater than the critical angle. However, the intensity of transmitted wave will decreases exponentially with the thickness of the layer of air. So in this case, there occur decrease in the intensity of transmitted wave exponentially with the thickness of the barrier. So the wave function will be, okay, it can be depicted like if this is the barrier. So the wave region 1, this is 0, this is L, so it will be something like this, and then its tunnel up to be like this. So this will be your transmitted wave, and this is your incident wave. This is V0. So this is direction X. So here we were illustrating of the wave function that has been illustrated over here in the through region corresponding to E less than V0. The reflected wave in region 1, okay, and exponentially increasing wave in the region 2 are not shown over here. So this is what we have shown over here. Thank you very much, and this is the end of this topic. Thank you.